Hi, welcome back to our channel and back to the tutorial for deep learning. Today we are to continue the session that is interesting thing that is image segmentation with IIT dataset. So here we have to see the practically that means hands-on time how to do or successfully do the image segmentation with the help of the dataset. For this one, I am approaching the Google Colab. Initially, we have to install the dataset based on the command. So this is the, from GitHub only, that is TensorFlow examples.gat. This is helpful to directly install the packages from the GitHub like that, whatever you want. So for that only we are using the TensorFlow example. And before going that image segmentation and this dark dataset, you have to get idea about what is image segmentation. Image segmentation is one of the very good technique or a technique or a method placed to divide the given image into multiple parts or we can say regions. So these multiple parts will helpful to get the accuracy and helpful for further investment analysis also. So there will be a lot of benefits there when going to go for the image segmentation concept. Here we are approaching the IIT doc dataset, free dataset, because it generally consists of here 2000 images, where it consists of a variety of images like the and each images belongs to classes like a dog, cat, or some other animals also. Majority of the images consist of dogs and cat only. So this is the initial one. Then we have to install the Keras. So Keras is one of the open source library placed for deep learning and machine learning and having n number of benefits. We use the Keras here. Then using the TensorFlow data sets and using the TensorFlow text data TensorFlow also. Then we are writing the package. You got to import the packages called import numpy as an NP and similarly TensorFlow and TensorFlow dataset as a TFDS shortly. So these are helpful to import the packages because we are going to run the program, that means image segmentation project with the help of dataset, that IIT dataset only, and we are writing the relevant coding. Then following the dataset where we are going to write tfdds dot load of oxford underscore IITPet3. So this is the doc dataset we are following and get from the GitHub with the help of GitHub from internet also. Then we are going to use the function called normalize. So this is concept of input image comma input mask, two stages there. For this one we are watching the formula. Then it will helpful to return the input image plus input mask also. Then we are going to load image. So once we consider the input image, we are consider about the load image for using the data point and maximize the and writing the point functions like image.resize followed by segmentation mask, that is the size of 128, 128, and input image input mask normalize input image followed by input mask and return at last return the input image input mask. So once you have segmentation concept, there will be images there and it will even for that image it generates a mask also. Then after movement some stage you go for the uh, segmented mask also and ground truth also is there that we consider later. Then we are going to train the data set with the help of trained length like that and followed by the normalize function. This is useful for normalize the input images. So when you go for the images, we are going to get the output also. The image should be normalized. That means all the images should be some form. Then again we are going to load the image. Then we are going to train images. And there will be two things in the when you go for data sets, that is train and staging. The train we are giving data set as a training. We are writing load image underscore sir comma num parallel followed by auto tune and test images followed by some coding. Then we are going to use the argumentation technique because we are going to create a class called argument where it consists of a keras and layers.layer and also calling the function called init and calls also. So argument. So generally argumentation techniques are the argumentation techniques are helpful to increase the training samples where n number of images you can generate. So if you have image, you can, for example, you have image of image one, we can generate 10 images based on the image only. That is image two, image three, and so on and so on. So argument is also very useful here. And train batches we are writing the code and display images we are writing the title as a input image comma true mask comma predicted mask. So once you give the input image as a cat, at last it predict is a cat only. Your test and training data everything correct means if you give a dark image, it is say dark like that, or whatever the exact like that. So for display information, we are writing the code called PLT dot title of title, then I am show, and plotter show also. And how we are going to display the coding with the help of the code called for images, comma mask in train batch start take off to, and sample underscore image sample underscore mask of images of 0, comma mask 0, and display followed by the coding called sample underscore image, comma sample mask. So since I told you that the Oxford IIT dataset has 2000 images, we are going to print the sample image, that's the input image. Suppose this is the input image, we have two masks like this. So for dark like that, and if your input image is a cat, the mask will generate true mask generators like that only. And we are writing the code, continue the code called a base model, because we are going to train and writing the code layer names also. Then we are writing the abstract and downloading data, and followed by then we are going to train the image segmentation unit model. So as of you know, about unit is one of the architecture, familiar architecture concept here, encoder and decoder concept. And we are writing the skip connections. The special of the major advantage of using unit is the concept skip connections. And we are writing the code and output classes. And due to avoid the time delay, I already generate the code. And because once execute the program, it may take some time. And we are going to generate the Keras graph. We are writing the Keras.utilitas plot underscore model of and show underscore shapes of true. So it takes some time. And input layer, and followed by the shapes, output layer, and ReLU function, depth-based conclusion, batch normalization, and etc. convolution, and everything. So it generates some of the somewhat long format or graph. Then after this one, we are moving to the next stage. So simple and easy. So we are not going to concentrate more here. So we are going to write the coding for create mask function. We are writing prediction mask code to tf dot math dot arg max predict mask comma args is equal to -1. Similar, writing the show prediction very important. So we are writing the show information data set. So we are following the pet data set only. So we are writing the relevant coding, and at last we are writing the show underscore prediction. So it will helpful to show the prediction, that is input image, true mask, and predicted mask. So we are giving the cat after training and testing. It will helpful to print the mask as well as the segmented mask also. So sorry, yeah. So accuracy. So here the accuracy is very important. How we are expecting the accuracy will be resolved. You can develop with UNIV or whatever there today. Let us cover some other architecture also. So this is a predicted mask here, and we are going to write another coding for display information. We are writing the image of some dog example, again generating like that only true mask for cat and predator mask like that. So an input image again true some generating, and approach test also very important. Once go approach test, it will check the quality of the data set, everything. So it generates like this. So sample prediction after approach 20, it display like this, and loss also. So with the help of this image segmentation concept, we can predict the loss value, everything. That is followed by plot dot figure and approach and loss value, and training and validation. This is a training loss, and this blue indicates the validation loss here. So we may get like this, and test images like this followed by 3. That is just I told you. So input image, true mask, and predict. So previously we are not getting, because now we are calculating loss function. We are getting more accuracy and predictions also. So getting output is very important, and input image there, again true mask there, predicted mask is there. We can go for further engagement analysis. So I hope that you understand today how we can successfully achieve image segmentation with the help of this dark data set. If you like the video, please subscribe and share with your friends. Thank you for watching the video. Thank you.